All right, unsigned integers, they can't be signed. So they are always non-negative and they can't represent negative numbers. How are they defined? So in C++, to define an unsigned integer, you use the keyword unsigned and then the integral type that you want, short, int, long, and then the identifier that you want to use, or the name of the variable that you want to define. The range of unsigned integers. So this time it's a bit easier to calculate than signed integers. Say we have, but it always depends on how many bits are used to represent your integer. So if we have an 8-bit integer or integral type and it's unsigned, then the range that it can represent is going to be 2 to the power of 8, and then we're going to subtract 1 from that. And it can represent anywhere from 0 all the way up to that number. And that's, we also have to include 0, and that's why we subtract 1 from 2 to the 8. Overflow. So how does overflow work in unsigned integers? Well, this time it is not undefined behavior like it is for signed integers. This will happen every time that there's overflow, and let's start with an example, I guess. So the lowest number in any unsigned integer range is going to be 0. But say we try to represent or assign -1 to an unsigned integer. What will happen? It will wrap around from the lower range that it's at, that it overflows past, to the other side of the range. So if we try to assign or represent -1, then it'll wrap around to the top of the possible top of the range representable by the integral type. So -1 might wrap around to 255 if it's I can't figure out how many bits that is. My mental math on that sucks. But it'll wrap around to the top. And so that's one of the reasons that unsigned integers are generally looked down upon in their use, is because especially when you're dealing with any kind of numbers, they're generally closer to 0 and they're not closer to the top end of the range that they can represent. So you get a lot more overflow errors when, or you run into a lot more times when overflow is something you'd have to account for if you're using unsigned integers. Another reason that they're looked down upon in use is because in C++, when you're mixing unsigned and signed integers in arithmetic, such as unsigned int x plus signed int y, then it will actually treat the signed int y as an unsigned integer, and then the result will be also treated as an unsigned integer. So if x was, if we wanted to do signed int x and x was 3, and signed int y is 2, if we tried to do y minus x, then we know that 2 minus 3 is going to be -1, but -1 isn't representable in an unsigned integer, so it would actually wrap back around to the top of the range of int on your system.